Hi Klaus, you have a very interesting project here. You love flying Stemme gliders. I don't know why, but somehow you are flying a lot with them.
Yeah, so it's hard to be a hard man like me. So Stemme is a quite heavy plane, but of course I have certainly more than 10,000 hours with the Stemme, so you get familiarized a little bit with that plane. And the combination between a quite nice glider and a motor plane is fantastic. So you can fly. So my idea is to fly with this around the world.
Oh, wow!
So in a mixture between gliding and especially with the motor in this case, actually we made with this motor glider we made a real motor plane because we have batteries, and the propeller actually is not foldable. And we make the first tests with a pure battery-driven plane, just to check all the electric systems that everything works fine. And of course, it's easier to have a fixed propeller. But after the tests, then we will have a FAS system which goes along here, and probably even with some garage that we can. Have a little bit better gliding ratio. It's not outside like that, like with most of the phase systems.
That's great. Here we have a closer look at the electric motor. I think this one, it's an MRAX motor. I have probably nearly a similar system in the 33ME, but what is here the difference? I think you're...
Yes, we, for the Stemme with that 900 kilogram takeoff weight, we need more power. So we use here the full power of the MRAX 228. So therefore, we have combined cooling, and therefore we need the right dimension for the cooling system. For this, we have 3 radiators which are independent here and cool the power electronics and the motor. So we run that motor with 70 kilowatt, and therefore we can make sure that even at hot summer at 40 degrees Celsius, we can do a self-launch.
Okay, so dual cooling means you have air cooling and also water cooling.
Exactly. So, and we have also the cooling system redundant. If one pump or one system will fail, then we still can continue flight. So we have 3 water pumps, 3 radiators, and the motor is also air cooled. With reduced power, we can run with air-cooled only. Just for the start, we need the water cooling.
What is the expected cruising speed then later on with the electric motor on?
You will be able to fly at 200 kilometers per hour, but of course, the efficiency for the battery, it will reduce the range, and therefore, if you want to maximize range, you will fly at the best gliding ratio, meaning for that glider 120 kilometer per hour, then you have the best efficiency.
Okay.
Of course, if you have an urgency and you will fly home fast, you can fly faster. It's more a question of the battery rather than the motor.
Okay, and what did you change inside the cockpit? It used to be it's an old glider, and you have here some equipment to some monitoring equipment and so on for the electric propulsion system.
Yeah, this is quite simple. We have here a bigger TFT display, a touch panel, so that the pilot has just to monitor the propulsion system. It will be exactly like a standard FAS system, except that we have redundant system. We have here 2 power switches, because we have the 2 power electronics. Everything else, we have a PODI for the speed. The PODI is also redundant, so just for the safety purpose.
So you don't use the gas lever?
In phase 2, we will have a range extender. And in that case, we will use that lever for the range extender.
That makes sense.
First, we fly with battery only, and it will be exactly like a standard FAS glider.
Okay. And then in the rear, there should be somewhere the battery, or where did you put the battery packs? In the wings?
Yes. So when we have done the design and the basic idea for that modification, we said no structural changes to make the project feasible.
Yeah.
So meaning we just integrate the batteries on the original mounting points from the rotors.
Okay.
And we have a very similar weight, so that for the certification it should be not a big deal.
Okay. What is the range with the batteries installed here, or with the range extender?
So the battery range currently is 30 kilowatt hours, meaning, and when we fly at the best glide ratio at 120, we need about 10 kilowatt hour, 10 kilowatt power, and therefore you can calculate nearly 3 hours if you do a level flight. And at 120 you can do the math, and you have the, but of course we need some capacity for the climbing first, for the start. But roughly, I think, Klaus, you will make flights for 400 kilometers.
Okay, without thermals. Without thermals.
Yeah. Yes. In the level flight.
Yeah. And then later on with the range extender, what is the weight of the range extender, and would you then reduce also the battery capacity? Because
yes, we have to, because it's mandatory that we keep the weight and the mass of the non-lifting parts. We have the range extender fully integrated in the Stemme fuselage.
Okay.
So that is an original Stemme fuselage.
Oh.
So you can see here industrial motor in Briggs and Stratton. This motor will have about 25 kilowatt on power. Of course, with 25 kilowatt you cannot start a Stemme, but you can do cruising flight with that. So we have here linked an MRAX 188, which delivers the 25 kilowatt power, and we can recharge this battery, and we have very limited capacity, just a bit below 10 kilowatt hours. We need the battery just for the start, typically, and maybe for some thermaling.
And the fuel tank is then in the wings, and it's a still existing fuel tank, or?
Exactly. So the Stemme from Klaus has a fuel tank about 120 liter. The motor fuel consumption is 5 liter. And now you can make the math how the distance Klaus will fly with that.
Has he a rating for night vision goggles?
Yeah, exactly. The limitation for him is probably the light, sunlight. I'm not sure if that is a limitation for him.
Yeah, that's true. And for the charging of the phase 1 glider with just the batteries, do you install a charger in there, or is the charger so portable that you can just take it with you for a trip?
Yes, we will offer multiple types of charger. If you want to have fast charging, you need a big charger, and this is not portable. No. But if you can use a portable charger, but then of course you have to charge overnight, you will need some time for charging.
Yeah, but it's a normal use case, so Klaus can make some expedition flights also with the batteries and charge overnight and come back the next day and so on.
Exactly. One important point for that fact, for Klaus, this system can recharge the battery in the wave during windmilling.
Oh, wow.
Yes, that function is already tested. I do it myself with the AVS glider. So you reduce the speed of the propeller, and the propeller is speed regulated. You can see that the power is going down to 0 at a specific speed, and then you reduce the speed of the propeller, and then you have negative power, and you're charging the battery.
And how much watts or kilowatts can you charge?
For this system, you can charge with 10 kilowatt.
Whoa.
Yeah, okay, the system has 70 kilowatt.
Yeah.
And of course, in windmilling, the efficiency is poor.
Really horrible, yeah.
Yeah, but 10 kilowatt is feasible.
Oh.
And that means if the Klaus is flying in the wave for 1 hour, he has already at least partially recharged his battery.
And especially if you need to descend, for example, because of airspace restrictions and so on,
Yeah,
you can use it as also like a small air brake maybe, and regenerate.
But typically at the wave you have enough climb, and you can use the energy of the wave to recharge.
Super cool project, but is it just let's say a project development thing, or do you really want to get this package to old gliders and to customers that want to install it? Do you intend to sell that?
Yes, you can imagine many Stemme pilots were already here and they came and said, we want that.
Yeah.
So, and therefore, yes, we will offer it also to other Stemme pilots, of course. Then the STC is required, which is a serious effort, and therefore it will need some time. So first this year, Klaus will have his flight, he will do a bus, and then we continue also with STC and optimization.
Do you have any rough price idea what it costs at the end?
So, yes, we have, because as you know, if a Rotax has a lifetime of 2,000 hours, and if that has to be replaced, it's a serious cost issue. And so meaning our target is that we will be in the same level like a Rotax replacement, and then the pilot can make a decision. Do I want to continue with a combustion engine, with a complex system, or will I continue with an electric system, which is simpler, has a redundant system, is more reliable, and of course it has no emissions. And
it's probably more silent as well to start at an airfield where some neighbors are...
Yeah, you know electric gliders, and the comfort of an electric glider is much better, correct?
Yeah, of course.
So no vibration, no fuel, less noise.
It's really a fantastic way of flying.
Yes, makes fun. And that we will convert the FES idea on that Stemme.
My idea is to make a little bit of content to show people what is technically possible today with the systems that are existing. Batteries are existing, small industrial engines are existing, but the combination of all this, the intelligent combination of all that will allow us flights with a third of the fuel that we usually have with a normal plane.
Yeah.
And so my idea is to make it in a historical content a little bit, for example, to fly from Toulouse to Dakar, then on the traces of AERO Saint-Exupéry, all the French heroes, and then to show a little what they did as pioneers. And so Dakar, then Brazil to Natal, and then going along to Buenos Aires, crossing the Andes, what they did. And you know, you can make very interesting content with that because you have historical films about them, what they did at the time, and to show it, what we can do it nowadays. Everybody, or most of us, know that flying is a little bit, before they were heroes. Yeah. They made wonderful things. Now you're, he's flying, he's a rich guy or something, which is stupid.
Yeah.
And so the idea is to show it's not the idea to fly as fast as possible around the world, to make stopovers, to make speeches on universities, to explain what we are doing and why we are doing that. I'm a fan of the engineering. So I'm not an engineer, but I say, okay, what would we do without all these engineers? When I see my engineer, what he made, for me it's a miracle. Yeah. It's so fantastic. With technologies which exists, and they adapted it for a plane, fantastic. And
when do you expect to make this trip?
Once I can fly, I will make check flights, of course, at first over land before I make the crossing. So flying in Argentina, probably to Central America, then go to North America. And one of my dreams is, I will do it alone, is to cross, next year is 100 years of Lindbergh, Charles Lindbergh flight. And to do it in an electric plane, even if with a range extender. So that would be a dream to do that from New York to Paris Le Bourget when they have the exposition.
Oh, wow.
Arriving there after 6,000 or nearly 6,000 kilometers of flight.
That's really...
I will do it alone because I need more fuel in the second trip. And it's possible. So you have 5,800 kilometers, something to do. And of course, it's not at all the same challenge that they had at the time because we have GPS, we have all what he made, flying with the weather, no weather forecast. He did not sleep the night before because he was disturbed by a mechanic and said, I have to sleep. And then he flew 33 hours and he arrived in the nighttime in Le Bourget. But I don't know if you read the book from Charles Leclerc, 33 and a half hours. It's really worth to do it.
Yeah, okay, that sounds like a very interesting project. I would love to do that as well at some point. But of course, like you said, you need to have the reliable system, and of course to have some electric propulsion in there is really a great way to go.
I think the electric system, I'm very confident in the electric system because it's a redundant system, but there is always a little risk. They took the risk as well, or much more risk than we have today. Today you have a satellite phone, even if for a technical reason you go in the water, you have still a chance to survive. You have all these things, you have a raft, you have all these things with you. And of course it's a challenge and it's not without risks. Yeah. But there are systems that you can do. For example, you can make a stage in the north of Germany in a piscine, in a schwimmbad, and they have waves, and then you try to go in the raft with the waves, and there are techniques to learn. Yeah. And so I think I will do that as well because shit happens sometimes, and I have only one combustion engine. Yeah. When you have the batteries, they give you a little bit more time, flight time probably, but
to organize a bit of help maybe, but not much more. Yeah.
To prepare your watering.
Thank you so much.
Oh,
and all the best for your trip. I hope to see that soon.
I hope it's before the end of the year we'll start.